electric potential and capacitance. Potential due to a point charge. Here plus Q is point charge. We have to find out potential due to it. Now we consider a point P at distance R from the charge and at distance x from charge. Another charge Q0 is kept. Now force between these two charges is given by F equal to Q0 divided by 4 pi epsilon naught x square. Now, suppose we move this charge from point A to point B, then we have to do some work against the force of repulsion, because this is positive charge, this is also positive charge, so force of repulsion will act. And now we want to move this charge Q0 from A to B, then we have to do some work, and that work we have to calculate. So let's write that work dW. So dW will be F dx cos theta, and here theta between force and displacement is 180 degree. Force is in this direction and displacement is in this direction, so theta will be 180 degree. F dot dx, that can be written as F dx cos 180 degree, and we know that cos 180 degree is minus 1, so we get minus F dx. Now we can calculate total work done from bringing charge Q0 from infinity to point P. So we write it as W equal to integration dW, and the limits we can put from infinity to this point is at R distance from this charge, so minus F dx, limits infinity to R, and we put the value of F, so it will be minus integration Q0 divided by 4 pi epsilon naught x square dx. We know that integration x power n dx gives x power n plus 1 upon n plus 1. Here n will be minus 2, so we can write W equal to minus Q0 divided by 4 pi epsilon naught, and this will become here n equal to minus 2, x power minus 1 upon minus 1, so we can say it will become minus 1 upon x, and limits it will take n. Now it will become minus Q0 divided by 4 pi epsilon naught, and from here we can take this minus sign, take it out, so it will become 1 upon R minus 1 upon infinity, and we know that 1 upon infinity is 0, so ultimately we get Q0 divided by 4 pi epsilon naught R. So this is work done. Now we know that potential is equal to potential V equal to work divided by charge moved. Work we have got as Q0 divided by 4 pi epsilon naught R times charge moved. Charge moved is Q0, so Q0 will cancel out, and we will get potential as V equals Q upon 4 pi epsilon naught R. Now let's consider electric potential at an axial point of a dipole. Here this This also represents dipole minus q charge plus q charge separated by distance 2a. This is midpoint of dipole. And this is the point where we have to find out the potential. And it is at distance r from midpoint of dipole. Now we can consider potential at P due to both the charges. So V is equal to V due to minus Q plus V due to plus Q, Q upon 4 pi epsilon naught. Distance will be R plus A plus Q upon 4 pi epsilon naught. Distance will be from here to here. It will be from pi to charge to P will be R minus A. Right. V equals Q upon 4 pi epsilon naught can be taken common. Then minus 1 upon R plus A plus 1 upon R minus A, which implies V equal to Q upon 4 pi epsilon naught times minus R plus A plus R plus A whole divided by R square minus A square. So R will cancel out. So we will get V equal to Q times 2A divided by 4 pi epsilon naught R square minus A square. But Q times 2A is dipole moment. We can also write it as P divided by 4 pi epsilon naught times R square minus A square. If we use approximation here that R square is greater than A square, in that case, expression of potential will become P divided by 4 pi epsilon naught R square. Clearly, potential due to dipole is directly proportional to 1 R square, or inversely proportional to square of distance. Now, let's see electric potential at an equatorial point of a dipole. This is dipole, and this is equatorial point. This is the midpoint of dipole, and this distance x will be equal to a square plus r square. Now, potential at P is suppose V, so V will be due to minus Q plus due to plus Q. So, minus Q divided by 4 pi epsilon naught, distance is x. Both are equal. So x square, either we can write the root of a square plus r square, but it's okay. First, let's write as x square q upon 4 pi epsilon naught x square. These two terms will cancel out and we will get 0. Hence, electric potential at an equatorial point of a dipole is 0. Now, let's see electric potential at any general point of a dipole. So, suppose this is point P where electric potential is to be found, and this is dipole plus Q, this is minus Q separated by distance 2A. This distance is A, this distance is A, and from midpoint, this distance is R, and from here it is R1. Similarly, from this point, this distance is R2. This angle is theta, and then this angle will be 180 minus theta. Now, we can say that potential at P is equal to V due to plus Q and due to minus Q. So it will be Q upon 4 pi epsilon naught times 1 upon R1 minus 1 upon R. Now let's find out what are the values of 1 upon R1 and 1 upon R2. So we consider triangle AOP. In a triangle AOP, we use cosine law. So according to cosine law, it will be R1 square equal to R square plus A square minus 2AR cos theta. So we can write it r square common 1 plus a square upon r square minus 2a upon r cos theta. Here we assume that a square upon r square is less than 1. So we can neglect this term. So this will be r square 1 minus 2a upon r cos theta r1 square. Now we take square root. So it will become r1 equal to r times 1 minus 2a upon r cos theta power half. We further write 1 upon r1 equal to 1 upon r. This will become 1 minus 2a cos theta divided by r power minus half. Now we use binomial theorem that says 1 plus x power n is roughly equal to 1 plus nx. So this will give 1 upon r1 equal to 1 upon r 1 plus, we multiply 1 by 2 here with negative sign, so negative sign will cancel out, 2 will cancel out, and we will get a cos theta upon r. So this is equation number 1. We have got the value of 1 upon r. Now we have to get the value of 1 upon r2 also. So we consider triangle POC and we apply cosine formula again. So let's see. In a triangle POC, using cosine formula. So here if we apply cosine formula, this angle is 180 degree. So we write it as r2 square equal to a square plus r square minus 2ar cos 180 minus theta. So r2 square equal to r square plus a square minus 2ar cos 180 minus theta, and cos 180 minus theta gives minus cos theta. So we get r square plus a square plus 2ar cos theta. We use again approximation, but before that let's take common r square. So 1 plus a square upon r square plus 2a upon r cos theta, which is r2 square. The approximation is a square upon r square is less than 1. So we can ignore this term. So we get r2 square equal to r square 1 plus 2a upon r cos theta. And now we further write r2 equal to r1. We are taking square root. So r2 equal to r times 1 plus 2a upon r cos theta power half. Now 1 upon r2 will be equal to 1 upon r 1 plus 2a upon r cos theta power minus half. Again we apply binomial theorem. 1 plus x power n is roughly equal to 1 plus nx. So this will give 1 upon r2 equal to 1 upon r 1 minus, if we multiply here by minus 1 by 2, so 2 will cancel out and we will be left with a here, a upon r cos theta. So let's put these values in equation this. B equal to 2 upon 4 by epsilon naught times 1 upon r1 minus 1 upon r2. We have got the value of 1 upon r1 as 1 upon r times 1 plus a cos theta divided by r, and the value of 1 upon r2 is 1 upon r within bracket 1 minus a upon r cos theta. So let's write these values. So we get v equal to q upon 4 pi epsilon naught, which is 1 upon r1 minus 1 upon r. We put the values q upon 4 pi epsilon naught, 1 upon r1, we have got as 1 upon r, so 1 upon r outside, 1 plus a cos theta upon r. Then we put the value of 1 upon r2. So that is 1 plus a cos theta upon r. So here 1 will cancel out. We will get q upon 4 pi epsilon naught and 2a cos theta upon r square. So we know that 2a times q is p, dipole moment. So p cos theta divided by 4 pi epsilon naught r square. So this is equation for potential at any general point due to dipole. Now let's see whether it is true for axial and equatorial point. So for axial point, theta equal to 0 degree. So if we put here 0, so we get V axial equals P upon 4 pi epsilon naught r square, and for equatorial point, theta equal to 90 degree and cos 90 0. So V equatorial will be 0. Thank you for watching.